Hello everyone, we are from Section 1, Group A6. We are going to present our project on solid liquid leaching of coffee bean. This group consists of 4 members, Ella Warasan anak lelaki Mania Rasu, Muhammad Ajmal bin Johari, me myself Noaina Jiha binti Jamaluddin, and the last one is Winitra Evangeline. This is the main contents in our presentation video. We will start with the introduction of food production process. Next, we will discuss more details on the extraction of coffee beans. The third one is parameters, and the last one is calculation for number of stages involved. We will start with the introduction part. Food production process is the converting of raw materials to the ready-made products for human use either in the home or food industry. Why separation process is important and how it involved in the food production process. There are a few other reasons, but we are choosing these 3 main reasons. The first one is quality control. Separation process, it helps to remove impurities and unwanted product. The second one is safety control, where the separation process can help to kill the bacteria that will make the food safer to consume. And the last one is concentration, where the separation process is possible to concentrate the output product, making it more flavorful or increasing its shelf life. As the technical team in one of the coffee manufacturer, we are going to explain on how separation method, which specifically to the solid liquid leaching process involved in turning the coffee bean to the instant coffee, where from the solid phase to the liquid phase. Next, I will pass to Ajmal to explain more details on the process and our block flow diagram.
Hello, my name is Muhammad Ajmal and I will be explaining the process description and workflow diagram of the manufacturing of coffee bean into instant coffee. So this is the block flow diagram of the overall process that will happen when manufacturing instant coffee. So I will be explaining from coffee bean and water into its end product, which is raffinate, extract, and into packaged instant coffee. For the pre-processing of coffee bean, the green fresh coffee bean is being roasted in the oven at 200 degrees Celsius and then turned into ground coffee in a miller. While for the water, it is being boiled over to an almost 100 degrees Celsius at a boiler. While in the static bed extractor, all the water and coffee bean has been pre-processed is being transferred into this extractor to undergo leaching process that will produce raffinate, which is the least solids, and extract, which is the instant coffee that we want from this process. So this is the one of the example of the static bed extractor. Well, this is the process of extract. The reason why we're doing this to make sure that to retain the aroma when it goes to freezing hole, the garner machine and sublimation, it can become a packaged instant coffee that can be sent to be as a product in the market. That's all for me.
So next I'll be talking about the parameters. So the first parameter is the solid liquid interface area. In addition, the smaller the particle, the shorter the distance the solute has to travel to reach the surface. This is likely to further speed up extraction. Moving on, the second parameter is the concentration gradient. To ensure a complete extraction as possible, a gradient must be maintained between the concentration of solute at the surface of the solid particles and that in the bulk of the solution. In a single-stage extractor, as the phases approach equilibrium, this gradient decreases and so does the rate of extraction until it ceases. But in multi-stage countercurrent extraction system, it enables a concentration gradient to be maintained even when the concentration of solute in the solid is low. This results in more complete extraction as compared with that attainable in single-stage or multi-stage concurrent systems. Next is mass transfer coefficient. An increase in temperature increases the rate of solution of the solute in the solvent and also the rate of diffusion of solute through the solution. Thus, the solvent is usually heated prior to and or during extraction. The upper limit in temperature depends on the nature of solids. Too high a temperature can result in the dried coffee powder having an undesirable flavor. That's all from me. Thank you.
Move into the calculation part where the number of stages required is calculated.
All the assumptions made for the parameters were extracted from the question 12.10-2 from the textbook. We use coffee powder as solute, coffee bean as solid, and hot water as solvent. This is a continuous countercurrent multi-stage system where is to be used to leach coffee powder from coffee beans by hot water. For the inlet solution with the untreated solid, L naught is equal to 850 kg per hour, Y A naught is equal to 0.941, B equal to 2000 kg per hour, N naught equal to 2.35. All these values are calculated as shown in the slide. XA n plus 1 is equal to 0.015. The points Vn plus 1 and LO are plotted in the graph. The underflow data from the table are plotted in this graph as N versus YA. The point Ln lies on the N versus YA in the graph. Also for this point, the ratio Nn per Yan is equal to 16.67. Hence, a dashed line through the origin at Ya equal to 0 and Na equal to 0 is plotted with a slope of 16.67 and intersects the N versus Ya line at Ln, making an overall material balance to determine point M. The point M is plotted with the coordinates XAM equal to 0.4 and NM equal to 0.977. The line Vn plus 1 MLO is drawn. The amounts of streams V1 and Ln calculated where Ln is equal to 1040.65 kg per hour in the outlet underflow stream and V1 is equal to 1006.35 kg per hour in the exit overflow stream. The operating point is obtained as the intersection of lines LOV1 and LNVN plus 1. Hence, about 4.96 stages are required and obtained from the graph.
To explain what happens when parameters changes affect the equilibrium stages. So, here we have two different figures. The first figure at the left is the one changes on its flow rate and its feed composition. We can see that from the leaching solvent and the feed solids. Okay, so here's the two graphs to illustrate the parameters changes that affect the equilibrium stages. So for the first graph at the left, we can see that the n is equal to 5, which is what happens when the parameters affect the changes, while the second one at the right is the original one, which is n equal to 4.96. So in conclusion, when one of these variables changes, the system equilibrium is disturbed and it adjusts itself until it reaches equilibrium again. So for this case, the parameter changes in our project is flow rate of the liquid mixture and the feed composition X and Y.